During this podcast, we're going to be discussing chemical equations. Again, use your notes, take notes over the presentation, put keywords or visual drawings on the left side in the main ideas, and then when you're done on the back side at the bottom, make a summary of what we talked about today. So as we've talked about in the past, all matter is made of atoms. Why would an atom want to combine with another atom? And the reason is it wants to become stable. So when an atom combines with another atom, this forms what we call molecule. When two different atoms join together, or even the same atoms, they form a bond. And atoms bond together for a very simple reason. Atoms like to have full valence electrons, valence shells, energy levels. Atoms will share, give away, or gain electrons when forming a bond. Substances in which two or more elements have bonded together form a material with unique chemical properties. The example, when you have water, which is two hydrogen atoms, bond with one oxygen atom, and we get H2O, which is water. So the product produced from these two atoms bonding together is called water, or H2O. So there are two types of molecules. There's an element molecule and a compound molecule. An element molecule is just when a substance has two or more of the same atoms, it is a molecule that is an element. So oxygen, two oxygen atoms would be O2. And that's the oxygen we breathe. So as you can see, example O2, the oxygen we breathe is made out of two oxygen atoms. Other examples might be H3, three hydrogen atoms, N2, two nitrogen atoms, and O3, which is the ozone layer. O3 is three oxygen atoms. So an element molecule only deals with one or more than one of the same element. Now the other type of molecule is called a compound molecule. That's a combination of two or more different elements. An example, when we have one sodium atom plus one chlorine atom, we get the compound NaCl. That's table salt. So as you can see, there's sodium and chlorine combined to make the compound molecule NaCl. Another example, again with water, two hydrogen plus one oxygen equals the compound H2O. So we get an H2O compound molecule, which is water. The examples above are compounds because the molecules is made out of different elements. So again, an element molecule is when they have only the same atoms or same elements. Compound is when they're two different elements. So chemical formulas represent a molecule or a chemical molecule. So the chemical formula of this model is CO2, two oxygen and one carbon. So this is an example. CO2 is a chemical formula, and just C by itself is a chemical symbol for carbon. The chemical formula uses symbols and numbers called subscripts to show the elements and number of atoms that make up the molecule. So if you see this chemical symbol here, H2O, 2, since it's below the H and the O, is the subscript. Now the subscript always goes to whatever letter or chemical symbol it is behind. So in this case, it's behind H, so that means there are two hydrogen atoms. So the subscript 2 only applies to the hydrogen because it's behind it. Does not apply to the oxygen. Oxygen, it's kind of like there's an imaginary 1 behind it, so it has an imaginary number. So there are two hydrogen atoms and one oxygen atom. So the one behind the oxygen is imaginary. So how many atoms are there? There are 3. 2 hydrogen, because you have the 2 there, and then since there's nothing there, you just instantly should know it's 1, or you should know it's 1 even if there's nothing behind it. So it means it's just 1 oxygen atom, so we have a total of 3 atoms. A lot of questions you'll see on tests are going to be asking 2 specific questions. How many atoms are there in this chemical formula, or how many elements are there in this chemical formula? So in H2O, there are 2 atoms of hydrogen again and 1 atom of oxygen. So there are 3 atoms total. Now, if it asks you how many elements there are only 2, hydrogen and oxygen. When we're looking at chemical formulas, one way we can tell how many elements there are, count how many, is to count the number of capital letters. Remember, every element starts with a capital letter. If there's 2 letters in that element, it'll be a capital letter and then a lowercase letter. So what I do is, when I'm looking at a chemical formula and I need to know how many elements there are, I just count the number of capital letters, and that's my number. So in this case, CO represents, we have 1 capital C, 1 capital O. So it's 1 atom of carbon and 1 atom of oxygen. So we have 2 elements, and they each have one atom representing them. Now CO in the other way is C little o. So that's not carbon and oxygen, that's cobalt, because this O is lowercase. So that's 1 atom of cobalt, and there's just 1 element there. When we get over here, Fe2O3 represents, so I got an F, capital F, and a capital O. So I should know instantly there are 2 elements in this chemical formula or equation. So Fe2, the 2 goes for the Fe, which is iron. So since the 2 is behind the iron, that means it's the 2 tells us there are 2 iron atoms, and the 3 is behind the O, so that tells us there are 3 oxygen atoms. So 2 iron atoms plus 3 oxygen atoms give us a total of 5 atoms in this formula. Another thing we have to take into consideration when dealing with chemical equations is what we call coefficients. Coefficients are the numbers that are in front of certain parts of the chemical equation. And what the coefficient tells us is that we have 2 H2 molecules. So instead of writing H2 plus H2, they just put a 2 in the front. And I'll show you some more examples in a little bit. And then on the other side, on the product side, we have 2 H2O water molecules. So 2 H2O. Instead of writing H2O plus H2O, they just wrote out 2, put a 2 in the front. So it's kind of like you're multiplying. So if I multiply 2 H2O, I would have, since I have H2, I have 2 hydrogen atoms already. I multiply that by 2, and it gives me H4, or 4 hydrogen atoms. And then at the same time, I multiply 2 times the imaginary 1 behind the O, and I get 2 oxygen atoms. So I have a total here of 6 oxygen, or 6 total atoms in this H2O, 2H2O. So here's a little breakdown of the parts of a chemical equation. We have the coefficient, which is a 2 in the front. We have the chemical symbol, which in all of these is H and O for most of it. The subscript, which is the lower number behind the element that it is representing. Then we have the yield sign, which is the arrow in the middle. So that yield tells us what it makes. And then on the other side, we have the chemical formula, which is H2O. And then we have the whole entire section, or whole entire box, or product, or reactant and product, is the chemical equation. So the chemical equation tells us about a chemical reaction that occurs. It shows the substances we start with, which are the reactants, and it shows the new substances that are formed, which are the product. So in the chemical equations, 2H2 plus O2 yield 2H2O. The 2 elements, the 2 molecules that we have here, 2H2 plus O2, are the reactants. They're reacting to each other. There's a chemical reaction occurring. And the yield, which is the red arrow, tells us what it makes. So it yields the product. And the product would be 2 water molecules. So reactants are the reactant or chemical reactions that occur, and they're always on the left side. And the products are what it makes, or it's kind of like what it equals. And that's the product on the right side. So it's almost like if you were doing math, it'd be like 2 plus 2 equals 4. Okay, so let's talk a little bit about the equations, or chemical equations, that we were dealing with, and kind of more of a visual learning about it. So again, we have the coefficient, which is right here. Both of these 2's are in front of parts of the chemical equation. So the first 2 right here is going to tell us that we have 2 H2's. Okay, we don't take take that 2 into consideration for the O2 part because it's not in front of it. It's separated by the plus sign in the middle. So when we have that, we only use it for the H2 part. So in the 2 is just telling us that it's almost like it's H2 plus H2. Instead of writing that out and writing it twice, they just put a 2 in front of it and just make it H2. So what I do with this is I multiply it. So I multiply the 2, the coefficient in the subscript, and that tells us how many hydrogen atoms. That means there are equals to 4 hydrogen atoms. Okay? Same thing if you just wrote it out. You would have H2 plus H2 equals, again, 4 hydrogen atoms. All right? So let's write that again. 2H2 plus O2 yields, again, remember, yields is, are like equal, is 2H2O, okay? So this is the reactant. That's the reactant side. And again, this right here is going to be our product that it produces. So we have the reactants that react together in chemical reaction and make a product. So again, if I asked you how many atoms are in this 2H2 plus O2, what we would do first is to figure out, we're figuring out atoms right now. So we got to multiply the 2 and the 2, and we get 4 plus O2 is 2. Now remember, we don't multiply that. No, we don't do that because that's not telling us we have 2 O2. It's saying we only have 2 H2 because there's a plus sign in the middle separating, so that's separate. So it equals a total of 6 atoms. We have 6 atoms. Over here on this side, when we do 2 H2O, that's telling us we have is equal to H2O plus H2O because there are 2 water molecules. So we could do it that way, or you could just multiply this, and then in this case, since there is no separation, they're together. It's a compound molecule. We also, in this case, multiply the 2 with the 0. So we have in this for the H2, we get 4 plus 2. Hydrogen and oxygen. So it again equals 6. Okay, and we could do it the same way with this. We multiply those 2, we get 4 hydrogen, and we multiply the 2 zeros, and we get plus 2, and again we still get 6. Okay. Now, one thing that you have to do to be able to do is tell if this chemical equation is balanced or unbalanced, and to know that they have to have the same number of atoms on each side. Okay, so when we do this, let's see, 2H2O. We have to see if they're the same number of atoms. So what I do is what we call a T-chart. Okay, and this is the T-chart. And right here you have your reactants and your product. Okay, so we break down each element by its number of atoms. So the first thing we do is we take how many hydrogen atoms do we have in our reactants? Well, we have the 2 here, and we multiply it by the 2. So H is going to equal 4, because we have 4. 2 times 2 is 4. How many oxygen do I have? Okay, total of this one, because I have 1 here, I have 1 right here, and then I have the 2 over here, because remember, the 2 behind the 0, or behind the O for oxygen tells me there are 2 oxygen atoms. So it's going to be a total of 1 plus 2 is going to be 3. Okay, so I have a total of H4 and O3. Now I go back to my product side. Go to the product side. 2 times 2 for the hydrogen is going to be H equals 4. But this time we're going to take the 2 and multiply it by the 0 because we have a compound molecule together. So they're together. There's no plus sign separating. So the 2 goes for everything behind it. So remember, there's like this invisible 1 there, okay? And so we have the invisible 1. So 2 times 1 is going to be 2. So 2 times 1 is 2. Now, when I look at this, when I look at this, I can tell that this is not right. And the reason it's not right is because H equals 4, those are correct, but the O's, or the oxygens here, are not equal. They're not balanced. You can't create or destroy atoms or matter. So the conservation of matter states that matter can neither be created nor destroyed. So in this case, if you looked at the other, if you would go back to the other ones, you remember I didn't have an O there for H2. I added the H2O. Okay, so since I added that extra oxygen atom, this is not going to be balanced because this is incorrect. Okay, so this is an unbalanced chemical equation. Okay, unbalanced. All right, so one other thing I want to show you is when we have different chemical equations, sometimes they'll ask you, they'll throw up a chemical equation like this and they'll say, how many elements, not atoms, elements are in this equation? So the first thing I do is I circle my capital letters. And right there I circle 3 capital letters, N, C, and F. And that equals 3 elements. Okay, elements equal 3. Okay, all you do is circle the capital letters. We're not worried about the 2 back here, anything like that. We're asking about elements. We're not asking, you don't have to say there are 2 iron. Well, yeah, there are 2 iron atoms, but in this case, we're just asking about the elements. So you don't have to say we have 2 of the iron. It's only 1. Iron is the only element. There's not 2 iron. If we're talking about atoms in this case, then you'd be right. There would be 2 iron atoms. So when we talk about elements, just circle the capital letters. And that's the easiest part, and then you're done. If I were to ask the same question, NaCl plus Fe3, I'm going to make it Fe3 now. What would be the number of atoms in this equation? Well, then we have to break down the elements. So we have 1 sodium atom, 1 chlorine atom, and since there's a 3 behind this iron, we have 3 iron atoms. So a total of 1, 2, 2 plus 3 equals 5. 5 atoms. Okay, if I put a 2 in front of this, that would change the whole thing. So now I would have 2 sodium and 2 chlorine. So I'd have a total, I'd add just 2 more atoms and I'd get 7. Okay, now I have 7 atoms. So these are some ways in which we use these to break down our compounds and elements. So if you have any questions, please bring them to my attention so I can help you understand this a little bit better.